Hello everyone. In this video we're going to be solving a homemade exponential equation. I think we've done a similar problem before, so this problem was adapted from another problem which was a competition problem, so it's not completely homemade. So this is an interesting problem because we have x to the x, which is something we basically talked about yesterday, which is an interesting function, and on the other side we do have, an exponential function. So at this point you can guess and check the solution, but we're going to look at it from a different angle. Definitely there's a better way to do it. So here's what we're going to do. First of all, separate the 5 to the x and 5 to the power 25. By the way, 5 to the power 25 is a very large number, don't evaluate it. So my goal is to bring all the x's together, so let's go ahead and divide both sides by 5 to the power x. And then that way we're isolating the gigantic number. And this is good because these two expressions, the numerator and the denominator, they have the same exponent. I'm not saying they have the same base, they have the same exponent. So we can kind of write them with a common exponent like this. If you have a to the n over b to the n, by the way, n doesn't have to be an integer, you can write this as a over b to the power n. Okay, makes sense? So that's what we're going to do here. We're going to write this as x over 5 to the power x equals 5 to the power 25. Again, that's a large number. We don't care what it is. It's just a constant. All right, so here's what I'm going to do. Again, at this point, you can guess and check, but there's a better way to do it. Here's what I'm going to do. The base is x over 5, but the exponent is x. So, can I make the same base and the exponent? Sure. If you can turn the exponent into x over 5, which you can, then you got it. So here's what we're going to do. We're going to take this expression and that expression and raise both sides to the power 1 over x. I mean 1 over 5. I meant to say 1 over 5, not 1 over x, because that's going to cancel out the x, but it's not going to help. Anyway, so we're going to raise both sides to the power 1/5, or it's equivalent to taking the 5th root. Okay? Now, obviously, these two are going to be multiplied, so this gives us x over 5 to the power x over 5 equals 25 times 1/5 is 5. So it's going to be 5 to the 5. You see what I'm talking about? This is really, really cool. Why? Because now we can equate or set them equal to each other. X over 5, if x over 5 is equal to 5, then this equation is going to work. I'm not saying that is the only solution, but it's actually the only solution. Is that the only solution? We're going to check that out. Anyway, so from here we can safely say that at least there is one solution for which x over 5 equals 5. And that means x equals 25. You probably already guessed that, I know. So the million-dollar question is this the only solution? And the answer is yes. Why? Let's go ahead and take a look at the graph of this function. That's going to give us some idea. And yesterday, remember, we talked about the graph of y equals x to the power x. So this should be fairly easy to examine. So this is y-axis, this is the x-axis. So I do have, unfortunately, or fortunately, I don't know, this function is not defined as 0 because 0 to the power 0 is not undefined, it's indeterminate. We don't know what it is. It could be anything. If you're doing limits, you probably know what I'm talking about. Anyways, but at 0, if we had a value, it would actually equal 1. But we don't have a value at 0. But if we did, it will be 1. So our function is going to decrease and then increase. Now, is this similar to the graph of y equals x to the power x? Yes, it is. It's just a little slower. So something like this, very relaxed, very relaxed. So it's going to go like this. It's going to decrease and then increase. You can find the minimum point by using, derivatives, but we don't need to worry about it. So now if you draw a horizontal line from y equals 1, you're going to notice that we hit x equals 5, and that is actually a point on the graph. We don't have 0, 1, but we have 5, 1 on the graph. But wait a minute. Isn't this the graph of y equals x over 5 to the power x over 5? So does that mean x equals 5 is the solution? No, we're not solving x over 5 to the power x over 5 equals 1. our expression is actually equal to something else, right? What is that equal to? It's equal to 5. So we have to find the point where y equals 5. And notice that this function, we don't care what the minimum value is or what the minimum point is. But we do know that after this value, which is less than 5, our function is going to increase all the time. So when you draw a horizontal line at y equals 5, you know, it is going to intersect your graph at a single point. Make sense? Therefore, there's going to be only one solution. By the way, this is not drawn to scale at all, and our graph should actually be more relaxed, I think. Our scale is totally off, but anyways, you get the idea. So x value here is going to be 25. Make sense? Okay, great. So let's go ahead and take a look at another approach. So here's another way to look at the problem. So we have x to the x equals 5 to the power x plus 25. Why don't we ln both sides? Because a lot of times lnning both sides helps, right? And we use it all the time. So if you ln both sides, then you can go ahead and move the powers to the front. You get x ln x equals x plus 25 times ln 5. All right, so let's go ahead and distribute x ln 5 plus 25 ln 5. It's just looking at it from an ln perspective, okay? Makes sense? So let's go ahead and bring the x's together. X ln x minus x ln 5 equals 25 ln 5. So we're going to try to get an equality from here, but let's go ahead and work out this a little bit more. So why don't we take out an x, because that's a common factor. That gives us x times the quantity ln x minus ln 5 equals 25 ln 5. So here's the deal. I want these two to be equal. So wouldn't it be nice if x was equal to this and this was equal to this, right? So what am I talking about? I'm talking about x equals 25 and ln x minus ln 5 equals ln 5. So now think about it for a minute. Is it true that ln x minus ln 5 equals ln 5 for x equals 25? That is the question. All right? To be or not to be, that is the question. So, and it's true. Why? Because if you think about it, ln 25 minus ln 5 can be written as ln 25 over 5 from properties of logs, and that's ln 5. So it checks. Or you can look at it differently. ln 25 can be written as ln 5 squared, which is 2 ln 5. So ln 25 minus ln 5 is 2 ln 5 minus ln 5, and that is equal to ln 5. Therefore, ln 25 minus ln 5 is equal to ln 5. Therefore, this equation is satisfied by 25, and everything checks. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.